muscle enable the arteriole to contract and arterial diameter, and also it is also able to relax and increase the diameter and therefore increase the blood flow. From the arterioles, there are several openings into very small vessel named as capillaries, and these capillaries are connected to each other and form a very extensive network of capillaries, and these capillaries will connect to each other, and finally they will end part of the venous system named as venules. As it is evident, when the blood enters the capillaries, it is high oxygenated. It has a high level of oxygen. By crossing the capillaries bed toward the venule part, as you see, the reddish color is reducing, and the color is turning into blue, and this is showing that blood is losing its oxygen. In fact, in the capillary system, the oxygen is able to leave the capillaries and enter the tissues, and by this means the cells receive the oxygen that they need. Another point that we have, and you should understand in the capillaries bed, is that just before the start of the capillaries bed, we have the final smooth muscle layer that is responsible for regulation of blood flow into the capillaries. These smooth muscle that we have at the beginning of capillaries and form a ring around the capillaries starting point are named as pericapillary sphincters. Pericapillary sphincters are able to contract or relax and increase or decrease the blood flow to one part of the capillary system. For example, if this capillary sphincter is then it prevents the blood flow to flow into this part. But this another sphincter is working independently, and this is very important in regulation of blood flow to the different part of the capillaries to the capillaries bed. It is different than the arterioles because in the arterioles, when the arterioles are contracted, the blood flow to the whole capillaries bed will reduce. But pericapillary sphincter generate a local regulatory effect on the capillaries bed. And you see that we have in different part of the vascular capillary system, we have such sphincters. In the capillaries, I will explain today that in this capillaries bed, the exchange of material, oxygen, gases, carbon dioxide, nutrients, and also different metabolites such as and carbon dioxide will take place. Except to this capillaries bed, we have some bypass mechanism or pathway that allow the blood, extra blood or additional blood that we have in the arterial end, to enable the blood to bypass the capillaries bed directly into the venous system. These connections are named as arteriovenous bypass arterioles. As you see, arteriovenous bypass are quite similar to the capillaries. They are single layer. They have single layered wall thickness, and but they have no any branching, and it receives and it sends the blood directly from the arterial end to the venous end. Also, we have a metarterial, are the vessels that are a little larger, and they have some connection with the capillaries. They have a smooth muscle around themselves, and they are able to contract or relax according to the need of the body. This is the capillaries bed. Now let's discuss about the function of the capillaries bed. The capillaries bed, as clearly, the capillaries bed is not constant and not similar in all parts of the body. In some part of the body, such as brain, the capillaries bed are forming the brain and are forming the blood-brain barrier because they are connected to each other very tightly and do not allow the freely movement of molecules across the capillaries membrane. In this part that we have tight junction and endothelial cells are connected to each other very tightly, the uptake of molecules, particularly large molecules, are taking place by some regulated mechanisms such as endocytosis or regulated endocytosis, as you see in this figure. For example, a large molecule such as insulin is not able to cross the capillary bed reach the brain cells, but by the mechanism of endocytosis, this molecule is being uptaken and sent from the capillaries into the interstitial space. In other tissues, such as liver, the capillaries bed form very loose connection to each other, and these loose connections generate some fenestrates or some openings that allow the large molecule to pass the capillaries bed easily. These capillaries bed are named as loose capillaries, and these are very important for the function of the liver, for example, because in the liver, body want to uptake some extra protein that we have in the blood, or when the liver synthesize some proteins such as albumin, these vessels allow this newly formed protein to enter the blood circulation. In other parts of the body, we also have different capillary systems, such as gastrointestinal capillaries membrane, glomerular capillaries membrane, and other membranes that we do not discuss about them. As I told you, the blood flow inside the capillaries is controlled by a mechanism named as vasomotion. The vasomotion itself, the definition of vasomotion itself, is the continuous frequent contraction and relaxation that we have in the metatarsials and in the ending part of the arterioles. As I told you, we have some sphincters that regulate the blood flow to the capillaries. The contraction or relaxation of these sphincters are not stable. Sometimes they form very strong contraction and totally stop the blood flow, and sometimes they relax totally, and sometimes in a middle. Therefore, this change that we have in the blood flow in the capillaries are named as vasomotion. And different factors are important for the vasomotion and the regulation of vasomotion that I will discuss about them in other session for you, inshallah. Inshallah, you have the class in phase, and therefore I will be able to explain these in person, and it is more easily understandable. When we are talking about the capillaries function, we are talking about not about the single time blood flow in one capillaries bed. We are talking about the average function of the capillary system. Sometimes the capillary system receives high level of blood flow, and sometimes it is not needed, and lower level of blood flow will form. As you see, the function of the capillaries is to bring blood to nearest distance possible to the cell of the body. In fact, in the body, we have no cell that, unless it has access to a capillaries bed in very small, in very distance. And as you see in this figure, the exchange of material between the blood and the interstitial space is continuously taking place in the tissues and in the tissues and between the capillaries and in the interstitial tissue. The factors that determine which molecule should move from inside to outside or from outside to inside is the and chemical properties of the molecule that is crossing the capillaries bed. What I mean by this, the molecule have some chemical characteristics. One of these chemical characteristics is its lipid solubility. You know that some molecules are very high or highly lipid soluble. Therefore, they are easily dissolved in the cell membrane. They are easily crossing the capillaries bed, regardless of the connection of the cell that form the capillaries bed. But other molecules are water soluble and not non-lipid soluble substances. These molecules are not able to cross the capillaries wall easily. They need some assistance. They need some pores or pathways, and therefore the permeability is lower. Another factor that affects the permeability of the molecule across the capillaries bed is the size of the molecule. The larger the molecule is, the lower the permeability will be. I mean that when we have a very large molecule, it has lower chance to cross the cell membrane, and very small are easily transferring across the capillaries bed. This figure is showing, this table is showing the different molecules that are crossing the capillaries wall and show their permeability in comparison with the water. If we have a water, if we set the water permeability to 1, you see that that salt, sodium chloride, that has a molecular weight of about 60 kilodalton, has the same permeability with the water. But when we come across the glucose that has the molecular weight that is 10 times of water, the permeability will reduce to about half. And when you see another molecule such as inulin that has a molecular weight of 5,000, the permeability will reduce to just 0.2. And eventually, that is largest component in the plasma and has a molecular weight of 69,000, has the lowest permeability across the capillaries wall. Another factor that affects the crossing of material, different material, across the capillaries wall is the concentration gradient or concentration difference. You know that when a molecule has high level of concentration gradient, it is more easily transferring from the capillaries vessel into the interstitium. And when the molecule concentration is reduced in the vessel, it is more likely to receive this molecule from interstitial tissue because of the difference in the concentration. This is showing a schematic figure that show the relation between the capillaries, the cells, and interstitium. As you see in this figure, the interstitium is not a hollow space. It is filled with some proteins, some glycoprotein, glycopeptides, glycosamines, and also water that is absorbed by these molecules and form a jelly-like material, and that is named as interstitium gel. This interstitial gel that form do not allow the freely movement of water across the between the cells, and this water is being trapped in this structure of gel. But there are some lakes or some invaginations that some water that are named as free water are being trapped between cells, and this free water is in balance with the water inside the interstitium and the balance of fluid inside the capillaries. You can see in this figure that there are some large proteins such as collagen, and these collagen proteins allow the tissue to retain its stability. And when we are talking about the filtration and perfusion of the cells by the blood inside the capillaries, it means that the material should leave the capillary to join the interstitium, and then from the interstitium it is entering the cell. Or on the other hand, the molecules we have inside the cell are able to leave the cell to enter the interstitium, and from interstitium they enter the capillaries. Now that I talk about the transfer of the molecule across the capillaries bed, one very, very important molecule that is very important in the blood circulation in the capillaries bed is the filtration of water across the capillaries bed. You know that capillaries, that water, we have high level of water inside the capillaries bed that generate and is responsible for blood volume. And on the other hand, we have some interstitial fluid that is trapped inside the jelly tissue interstitium, and this water is being balanced with the water that we have inside the capillaries bed. Now, please pay attention. We have four factors. That determine how much of blood volume or how much of blood water is able to leave the capillaries and how much is able to be absorbed. There are four factors that determine the determine the amount of filtration of water from the capillaries into the interstitium, and these four factors should be learned very, very well. The first factor is the capillaries pressure. You know that we have a hydrostatic pressure inside the capillaries. At the arterial end, it has higher than at the venous end, and this high level of pressure tend to send the water or tend to filtrate the water from the capillary into the interstitium. This pressure is responsible for filtering water from the capillary into the interstitium. Another pressure that we have is the pressure that we have in the interstitial tissue. And in the interstitial fluid pressure is normal, it is negative. Therefore, it also tends to absorb the water from the capillaries bed. But what about two other factors? One, interstitial fluid colloid osmotic pressure. It means that we have some protein in the interstitium, and this protein tend to absorb water from the capillaries bed, because these large molecules generate osmotic pressure, and osmotic pressure is being absorbing the water from the capillaries. Therefore, I can say that in normal situation, the capillaries pressure, osmotic pressure in the interstitium, and negativity of the fluid pressure inside the inside the interstitium, all of them tend to absorb the water from the capillary into the interstitium. But on the other hand, we have one very important force that tend to absorb water from the interstitium into the capillaries. In fact, this force, that is the osmotic colloid pressure of the proteins such as albumins that we have in the blood, and they generate a very strong absorptive pressure. In fact, when you are seeing these four factors, from these four factors, three of them are tending to send the blood out from the capillaries, and one is tending to absorb the water from the interstitium into the capillaries. And in normal situation, we have a net balance between these factors. And I will talk about this factor a little more. You are seeing this figure. At this figure, you see that at one arterial end, the blood flow enter the artery, and it has higher level of pressure. And because the pressure is high, this factor is high, very high. Therefore, because the pressure is high, therefore blood will lose its water, and water will infiltrate into the interstitium, as you see by this red arrow. But when the blood reaches the middle site and then in the part of the capillaries, the pressure will drop to very low levels. And on the other hand, there is not only the pressure filtered water outside the capillaries bed, but also it increase the interstitial pressure and also increase the capillaries osmotic pressure. Therefore, at the venous end, there will be a net absorption of water from the venous end, and this generate a continuous cycle of filtration and absorption in the vascular system. This is showing a schematic figure. As you see, at the arterial end, the pressure is about 32. At the venous end, it reached to about 15. And across this area of capillary bed, the filtration will decrease, and the filtration will decrease, and absorption will take place, as you see in this figure. This principle is very important because allow the water to generate a cycle of filtration and absorption in the vascular system. Therefore, in summary, I can say there are four factors: hydrostatic capillary pressure, interstitial fluid hydrostatic pressure, plasma colloid osmotic pressure, and interstitial colloid plasma pressure are the four factors that determine the level of filtration. Let's see the digit of this factor. At the arterial end, as you see here, at the arterial end, the capillary pressure is about 30. The negative interstitial fluid pressure is about 3, and the interstitial fluid colloid osmotic pressure is about 8. Therefore, the sum of these factors that all tend to filter water from the capillary into the interstitial tissue, 41. Forces that tend to absorb water from the interstitium back into the capillary's bed are just one force, and this is the plasma colloid osmotic pressure, that is about 28. Therefore, the net total net inward force is about 28. If we measure the balance between these two forces, we have a 41 force inward, outward, and 28. Therefore, we can say that there is a net pressure for filtration of about 30. It means that at the arterial end, we have a huge amount of filtration that is taking place. But what about the venous end? At the venous end, the osmotic pressure inside the plasma is still the same, 28, but the forces that tend to filter fluid outside the capillary's bed is a little different. At the venous end, the blood pressure is dropped and reduced. Therefore, the capillary's pressure inside this area is reduced to 10. The negative interstitial fluid pressure is also the same, -3, and the interstitial fluid osmotic pressure is 8. Therefore, total outward force that we have in the venous end is 21. Therefore, if we subtract this inward and outward values in this figure, you can see that in the venous end there is a net movement of water from the interstitial tissue into the vessels. Let's see the average of these forces not in the arterial end or venous end, in total capillaries. In total capillary, we can say that mean forces tend to move fluid outward are about 28.3. The mean capillary pressure is 17.3, negative fluid pressure is 3, and the interstitial colloid osmotic pressure is 8. And therefore, we have a 28.3 millimeter of pressure from the capillaries bed into the interstitium. But on the other hand, what are the mean forces tend to move fluid inside? The only factor that absorb water from the interstitium into the capillaries bed is plasma osmotic 8. And as you see, the summation of mean forces between the outward and inward is just about 0.3. It means that in normal situation, we have a net movement of water from the interstitial, from the capillaries bed into the interstitial system. And this is very, very little amount. But this little amount could generate problem for us because it allows the blood to water, and over time it can be very dangerous because it lowers the blood volume and even can cause death. For this reason, we say that in normal situation there is some filtration of blood, but filtration of water. But normally we have another vessel system named as lymphatic system, and lymphatic system is responsible for reuptake the extra water that enter the interstitium, and this is the lymphatic system that I will explain it in the next session, inshallah. Generally, therefore, I will finish the class here, but in summary, I can say that the capillary system are forming a situation that allow the material to perfuse between the cells and the interstitial tissue, and then inside the vessel, and these forces for the water, the forces is outward. But you should know that this very little force could generate a very severe edema if there was not lymphatic system in the body. In the next session, I will explain in the next session that we have in face, inshallah. We will explain the lymphatic system, the function of the lymphatic system, and how it is working for us. Today, I will finish the class because of the Ramadan and your fasting. I will make the class shorter for you, and inshallah I will explain them for you in the next session, the lymphatic system. If you have any question, I'm ready to answer.